Today we're going to discuss about the 16:1 multiplexer. As its name suggests, we are having 16 inputs, right? And we are having only one output, that is denoted by Y. So 16 inputs means starting with D note, D1, then up to so on D15. Correct? So in 16:1 mux, how many are the select line? I told you the formula 2 raised power m is equal to n. So here n is 16. So 2 raised power 4. So m is equal to 4. So we are having 4 select line. One is S0, another one is S1, then we are having S2, and then we are having S3, right? So we have to draw the truth table regarding this. So we are having 4 inputs, right? 4 select line means we are having 4 input, means we are having what? We are having S0, S1, S2 and S3, correct? So in this we are having like 16 in 4 we are having 16 possible combinations, right? So we'll have like uh, we are having 8 times 0, 1 2 3 4 5 6 7 8, then 8 times 1 and so on. Okay, then we are having 4 times 0, 4 times 1. Okay, then again 4 times 0 and 4 times 1, so on. Then we are having 2 times 0, 2 times 1, 0, 0, 1 1 0 0 1 1 and so on. Then 0 1 0 1 0 1 and so on. Okay, now what is the output? For the first case, the output would be D naught, then D1, then D2, then D3, it goes up to D15, right? Clear? So we have to draw the expression from this, that is y is equal to, that would be E is in the multiplication. Here one more input is there, that is the enable pin. I told you enable pin should be always 1, then only we'll get the output. So E would be, so it is S3 is 0, so it would be S3 bar. S2 is also 0, so it would be S2 bar. S1 is also 0, so it would be S1 bar and S0, and then we'll multiply it with the D note. S0 is also bar. Okay, then for the second expression, S3, S2, S1 are 0, so we'll write down S3 bar, S2 bar, S1 bar, but S0 is here 1, so we'll write down as it is, S0 as it is, then D1. Okay, then again we are having for the third one, S3 and S2 are 0, S1 is 1 but S0 is 0. So on the number we are having 0, we'll put bar, S3 bar, S2 bar, and then we are having S1 and S0 bar, then D2. Okay, so on we can complete it, and in the last we'll get all are 1, so S3, S2, S1, S0 and D15. Okay, now what we need to do, we need to draw the logical gates expression. So how many are the select line? 4 select line, right? So we have to draw the 4 lines. Okay, so one line is of suppose S0, this one is of S1, this one is of S2, and this one is of S3. Okay, again we need note also, so we can draw a line like this for the note gate. This would be S3 bar. Again we need S2 bar also, so we'll draw this one S2 bar, then this one S1 bar, then this one, that would be S0 bar. Okay, so let's see our first S3 bar, S2 bar, S1 bar, S0 bar, all are bar. So from black line will connect S3 bar, S2 bar, S1 bar and S0 bar. All are in the multiplication, so we'll provide AND gate, and one more input is also there, D note. Okay, so we'll write down D note is as it is, like here D note. Okay, similarly we'll do it for the second also, S3 bar, S2 bar, S1 bar, then S0 as it is. So again we'll connect S3 bar, S2 bar, and S1 bar and S note with the red line. Okay, then we are having one D1 also. Similarly, we'll do it again like for continuation. Then as you know that all are in addition, so for addition we'll use which gate? AND gate, right? So this would be the final expression, and in the last we connected with the enable pin also. So this is our 16:1 D multi, sorry,